Cool. Is everybody able to hear us online? If you can you give us a bit of a thumbs up? Please, got some food, got some tea or wine. Then I think we're going to try and kick things off. We've got quite a small crowd tonight. Hopefully not. They're not all up to the other workshop 17. If they have, they've just like gate crashed somebody's like corporate event that's happening there this evening. Cool. Alrighty, well, we'll crack on. Thanks very much for coming to our final Snowflake user group. Hopefully you guys online can see us and hear us all right. If you have any challenges, then we've got someone monitoring the chat. Drop all your messages in the chat there and we'll hopefully sort you out. But hopefully this month it's better organized than it was last month. That's because I didn't do it. So hopefully everyone's joined us online. All the guys from Joburg, all the guys from Durban, so that's really good. Tonight's agenda, this is going to work. Let's make it come into life. Hang on. There we go. So welcome to the Snowflake user group. That's where we're at now. I'll do a couple of announcements, and then we've got Peter House. Is that right? That's my best Afrikaans. He's going to talk to us from Wonga. He's done some cool stuff with geospatial data. He's going to take you through his learning experience for how he's used Snowflake to solve some problems and some other tools as well. I'm going to give a little kind of intro to geospatial data. I don't know how many people here have worked with geospatial data before and know it very well. If you do, then this is going to be like a recap, and it's like really low level, entry level type stuff. I'll show you some cool things that we've been doing with geospatial data as well. As always, there's a quiz at the end, so keep your ears peeled. The quizzes are technical, and then obviously there's plenty of drinks I can see outside and plenty of food, I think, as well. So please hang around and engage with your peers. If you've been to our user groups before, you'll have seen these slides. Why are we here? We're here to discuss best practices. So that's what Peter's going to bring tonight. Grow your professional network and stay current with all things Snowflake. If you haven't joined the Snowflake user group proper, then scan these QR codes. We're QR code heavy. So, yeah, I'm one of the kind of group leaders of the Snowflake user group here in South Africa, along with Marisa. So we both come from a company called Data Lab with Snowflake partners. We started the user group about a year ago, 14 months ago. We had our 1 year birthday a couple of months back. We're going to try and get to a cadence next year where we're running these events almost monthly. So we're going to take a bit of a break now. South Africa goes to sleep for the next 2 months. We'll pick things up again in February and hopefully run a whole series of events February through to November. So going on to the previous slide, we're really looking for speakers to come and present their use cases. No one wants to hear from me every month or from any of our team. I want to hear from you about your stories, how you've been using Snowflake, your learning experiences, like from the trenches. So please contact either one of us. You're welcome to join the actual steering committee for the user group or just give us your ideas. The community's grown quite a lot. We went from 0 to upwards of 350 members now. Last month, attendance was much better. We had about 70 or 80 people, so clearly people are already on leave or on holiday. Or workshops, everything. Just feel proper. Yeah, there we go. This will be part of the quiz. So yeah, case studies, innovative use cases. I think what Vince's done is going to show you later on. It's quite cool. It isn't that much to do with geospatial data. It is quite a cool domain of data to work with. It sits in that kind of unstructured data set kind of source of data. Got a couple of little demos as well. Hopefully show you how you can bring some of that geospatial data together with one of my pet favorites, which is all the AI SQL stuff. And then, we want your best practices and your lessons learned. So please contact us, because otherwise the community doesn't grow, it doesn't learn. Join us at Chapter League, I think we said that. Cool, we're in South Africa. We're wanting to run these events physically in Johannesburg. We attempted a couple of times this year. We have a plan next year to run them physically. We'll do them as kind of sister, so they'll happen at the same time. So we can take advantage of the coordination of events. So we'll actually have Kaizen Workshop 17. If you're online and you're interested in that, then get us upcoming events. Well, there aren't any because it's the end of the year. So join the Snowflake user group. Otherwise, if you're really keen, you can go back and relive the Snowflake Build Conference, which was on the 5th and 6th of November. Or no, 4th to the 7th, sorry. There's loads of content now. It's all available online, so you can watch all the recordings, loads of announcements, loads of technical walkthroughs. So, if you're a developer, if you're a nerd, data engineer, analyst, what have you, then by all means go back to the Build Conference website and watch some of the content. Cool. That's the intro. I don't think I've missed anything out. It is a small group, so if you have got questions as we go through, I'm sure Peter and I'm certainly comfortable to answer any questions as we go through. If you're online, then just pop your questions in the chat and Reeza will read them out. Okay, so I'm going to start with the really basics of geospatial data. So it's hard to get a point, the geospatial point in beyond that, we start to connect these points together and we get to things called line strings. In some of the demos later on, we get line strings and we also get things called multi-line strings. So you can group lots of these different lines together. We also get polygons. So this is probably more familiar to people, like the geospatial points, but also we can get polygons and we get these interesting ones as well, which are multi-polygons, where you get shapes which obviously have more than one kind of shape within them. So this is a good example of something like South Africa, for example, with Lesotho smack bang in the middle. This makes them typically harder to work with when you're doing geospatial analysis. So we have these kind of cutouts that can become more interesting to work with these things. And then we obviously have the coordinate system that we're all happy to work with. So, obviously we've got latitudes and longitudes. And if you come from one part of the world, you have the meridian line that goes through Greenwich. Something about 1824, the powers that be at the time, decided that the meridian line should run through Greenwich. Good for them. Then obviously we've got places like Manhattan, and we've got Manhattan down here, kind of stuff. So, we use these coordinate systems to obviously locate ourselves geospatially to places on the planet. It's not as straightforward as that, unfortunately. We have all these different ways that we can go and stretch the map. So this is, I'm not even going to try and pronounce this, but this is the kind of traditional way of actually like seeing the Earth and the planet. The problem with looking at the planet like this is that get down towards the two kind of poles, the country shapes generally get kind of stretched out and they don't actually resemble their real kind of shape. In any case, this rectangular shape is basically what we would call the geography data type. So if you're going to go and store anything in a geography data type in Snowflake, it gets stored using this kind of it's what called an S-grid. So basically your also your projection of how you want to see the planet. If you want to look at the planet in a kind of flat way like this, then these particular representations of the planet or geospatially, they get stored in a geometry data type. So they're stored in very different ways. So this is geometry data types and this is geography data types. And you can specify using these numbers down here which projection of the planet you actually want to use. So using geography by default, it is this 4326 projection of the planet, which is kind of atypical working with geospatial data. So getting into some of the weeds now. So you've got geometry data types and you've got geography data types. Geometry, 2D, you're typically storing data in XY coordinates. And then in geography, we're typically storing them in latitudes and longitudes. And you can switch data between these. So you can cast values between these two data types. It sees the Earth as flat. In this example, it sees the Earth as spherical. And there's one other important reason or distinction between these two different data types. And that comes to do with how you measure distance. So obviously in flat, if you're a flat earther, then you're measuring distances across the planet like this. So if you put something on the east coast of the US and you're going to like maybe Japan or somewhere on the right-hand side of Russia, actually these two things are pretty close to each other in the real world. In terms of how geometry calculates distance, it calculates distance across the actual plane. Whereas if you use geography, it actually calculates it more appropriately. There's a really big, that's one of the clear distinctions between using a geometry data type and a geography data type is how they actually calculate distance. You try and use one of the functions that uses distance. Well, so that's like a little kind of precursor to geospatial. Geospatial SQL. So how does this actually manifest itself inside of SQL? So Snowflake's pretty cool compared to maybe some other databases. Behind the scenes, it basically stores geospatial data in kind of like a single format. And you can render it basically in whichever format you want to. So you can actually set your default. So the typical way of looking at geography data when you kind of store it inside of Snowflake is that when you read that data, you'll see something like this on the left-hand side. You'll see geography, you'll see your coordinates. So this is telling you what type of shape we're actually looking at. We're looking at a point with its latitude and its longitude. You can also go and expose this in different formats. So WKT stands for well-known text. If any of you work with tools like Power BI and you put geospatial data into Power BI, it stores it in this well-known text format. And it's actually quite nice because it's quite readable. So you'll end up seeing, instead of things like point, you'll see it say line string, you'll see it say polygon, multi-polygon. So you know what kind of data type you're working with or what kind of shape. WKB, well-known binary. And then GeoJSON, which is a kind of standard JSON format for sharing data. So typically, when we've been doing this kind of work, we typically work with either all of these, apart from the binary one. I've never really had the experience to actually use that. The well-known text for tools like Power BI, GeoJSON for sharing data between different systems, particularly if you're importing data, you'll find a lot of third-party providers provide data in this format. And then geography and being the kind of standard inside of Snowflake itself. You'll see in these demos that they use a load of tables that come from the Ordnance Survey. So Ordnance Survey in the UK is kind of responsible for producing and managing all the geospatial data for the government, essentially. And they recently, about 6 months ago, put a whole load of data sets, free ones, which are quite nice, quite like free, but also some of their premium ones. And so you'll see a little bit later on, hopefully, a couple of demos where I've used these data sets because of their completeness to actually demonstrate a few pieces of research.
So something global.
No, unfortunately not. Most of it is to do with just the UK, but there are other data sources which I'll point to later on, which have got like good global reach. It's
So I just look at the example state. What's the difference between geography and geoadjustment? Consistency.
Yeah, they're pretty. So you're right. So basically, in this instance here, I've set my default as the user, me when I'm working inside of Snowflake, to be JSON kind of output. But I can equally set my format to be WKT. In terms of like constructing like points, so we saw what a point was earlier on. It's a latitude and a longitude. So you can take your geography, you can dissect it if you want to. So you can use functions like this ST_y. So there's a whole load, and I don't know why the prefix ST, but there's a whole load of functions that are prefix ST. These are all to do with geospatial analytics. So here I can pass a geography data type and I can extract X and Y coordinates on that. And then I can take those and I can put it back together again. So this is basically showing you how you can use different mechanisms to basically construct a geospatial entity. So when you're doing lots of geospatial analytics, you're comparing geospatial data types with one another. So you can say, does this point exist within a specific shape? So let's say, for example, we have like the Western Cape as a boundary. I can go and ask the question, does this particular point exist inside of or outside of that particular boundary? And that's how you do a lot of like data engineering in terms of like doing joins, things like that. So here's just an example. So here I'm using a product called geojason.io. So this is a website freely available. It's actually was bought out by Mapbox. And basically, you can paste your GeoJSON payload in here, and it'll actually render you different shapes and stuff like that. So there's no native kind of visualizer inside of Snowflake itself. You're going to have to do something in order to visualize the data outputs. Here, I'm looking at things like roads. So if you've ever been to the UK, there's a road in the UK called the M25. It's a big circle that goes around the outside of London. This data set basically provides you with lots of different segments of the M25. So it's like short, like 100-meter lengths of the M25. So this geography data type in this table draws 100-meter like lengths of the M25. So if I want to now combine all these together and see the whole of the M25, it's pretty straightforward in Snowflake. Literally just use this stunion function and basically pass it the geography data type. It's going to go and add all of those rows up together, all of those different line strings together. And you can't see it down here. This becomes a multi-line string. So each of those basically becomes an array in this GeoJSON. So now you can start to construct quite complicated like shapes and images that you can then render on a map and show to a user. One that you may be more like familiar with is like polygons. So here we're using this building data set from the Ordnance Survey. So pretty much every building in the UK has a unique identifier. And so you can get the boundary lines of every single building within the UK. And what's really cool is the Ordnance Survey scans the UK once every 3 years in totality. So they're continuously doing this, flying drones and planes and goodness knows what, basically doing a whole load of kind of image extraction to identify buildings, to identify different types of land. And they basically monitor this over time and can give you a history of how that piece of land has changed over time. So interestingly, I was speaking to some guys on the survey a few months ago, and they were saying that, like, the cup, for example, you look at solar panels on the top of their roof. So, 3 years ago, you didn't have solar panels. Now we can identify you've got solar panels, and they can start doing that kind of analysis. I dropped the word solar panels in there because that's part of my demo later on. Then we've got multi-polygons. So here, this is a shape of a particular, like in the UK, we have these things called county councils. This is actually where I'm from, a little place called Colchester. It's actually a multi-polygon. You can see maybe on the fringes here, there's tiny little shapes which aren't actually connected to the main shape. So if you were to actually go and look at this, it's actually made up of about 20 separate little shapes that make up the boundary of the Colchester district. It's a bit like a ward in South Africa.
So we also join with the boundaries. Does it automatically join when there's a problem?
If you have a polygon, it's a closed shape. So if you have a polygon, all the lines must actually join up. And here you've got multiples. You've got like a big shape and you've got a couple of small fringe ones. And so basically it stores those all as one object. So when you start doing calculations and math on those kind of things, like going, what's the center point? Then it's going to work out what's the center point of all of them, not the individual ones. So you have to do quite a lot of work when you get to use multi-polygons to make sure that things actually work in the right way. What you can do is you can like make, with some effort, you can like join the kind of complete outer boundary, but now you're creating a brand new shape. So that's kind of work you do yourself. Cool. So that's like the basic shapes. That's the basic kind of interaction that you can have with geospatial data in Snowflake. The other thing I just wanted to mention is geospatial indexing, and this is really interesting if you want to get performance. So there are three main. I'm going to skip this slide because it's way too close and there's too many things. There's basically three like main indexing systems that you can work with. So there's H3, which is based on hexagons, and I know Peter's going to talk to this later. This was developed by Uber in order for them to optimize how they do route optimization. And you've got S2, which was developed by Google, and it's kind of got curved kind of squares. And then you've got Quadbin, which was developed by Microsoft. So there's these three different mechanisms that you can actually use to index data. So you can basically draw shapes over the planet. I particularly like H3 because of its consistency. So it's basically hexagons that roll up into each other. And there's lots of data providers now providing data in this format so that you can join it all together very seamlessly. This is native to Snowflake. So there's a whole load of functions inside of Snowflake that allows you to convert data, latitudes, longitudes, shapes, what have you, into this H3 index. And what's interesting about it is the actual H3 reference tells you where it actually lives. So it tells you what its parents are and it tells you what its siblings are just by looking at the reference itself, which makes it very easy then to traverse from one cell to another. And therefore, that's how you get the performance because the actual number is meaningful. S2, I'll show you some of these examples now. So this is what Google's like referencing system looks like. So it's predominantly developed, I think, for images and being able to like overlay like Google Maps and you to be able to traverse from higher grade images down to lower grade images. So this is how they see the planet. They map it out in this kind of weird way. Microsoft's, again, this is quite intelligent. You start off with four main squares, and then those squares then get broken down. You can see the referencing system here. So if you're in square 20, your parent is number 2. If you're in like 22, your parent is 20 and your parent is 20. So you can actually figure out how to traverse up and down the actual geospatial kind of index. But the interesting one is the Uber's one. So basically they have, I think it's about 15 different layers of hexagons. And like I said, the nice thing about hexagons is that they keep their shape consistently. So you're able to know what the reference is for this one and this one, all of its children or all of its siblings and its parents. So basically how it rolls up is you take a hexagon like this and the parent basically is kind of just twisted slightly and goes bringing these children. So this is part of one of the challenges with this is that as you go up the hierarchy, it does change. So it's not naturally, so the numbers that you aggregate at this layer, the children, won't necessarily add up to the parents. So there's a level of error in the calculations. But for the purposes of what Uber's developed it for, i.e. how long does it take to travel from here to here, basically work out what travel times are through these hexagons and then can roll things up. If you go and look at Uber's research like YouTube channel, it's got amazing demos of how they use this stuff and the analysis that they do. So essentially at its lowest level, level 14, the sides of these hexagons are really, really small, they're in meters. And then you get up to the highest level here where basically you've got 4 hexagons that wrap the planet. And their lengths of the sides are quite high. So typically, like a good place to work is somewhere around here in terms of like being able to do some kind of analysis. So that's what I mentioned, these different indexing systems, H3 specifically because it's native to Snowflake and you can play around with it really easily. There's some tools that you might be able to use, so called Blatant Snowflake Marketplace. So there's loads and loads of data sets on there. I'm going to use 3 of them just now for a demo. There's this HDX website, which is the human data website. They've got 20,000 different data sets available, predominantly geospatial data. There's one data set on there which is really cool. Again, referencing back to that H3, it's called from a company called Contour. They've basically mapped out the planet and put the population into that H3 index. So you can go and work out what's the population of New York and aggregate that up, overlay that with other data that you have. If you normalize it all to H3, you can get all that data to talk to each other nicely. And using these to do analysis is much more, let's call it accurate, much more consistent than using random shapes that we use, like for wards and like provinces and things like that, because they're typically political boundaries or they're boundaries that have been derived from geospatial characteristics like rivers and mountains and things like that. Here you have a consistency in terms of, the shape is consistent, the values are consistent. You can compare one hexagon with another and they're the same geospatial kind of size. GeoJSON.io, which I mentioned earlier on, you can paste your GeoJSON in here. You can see what the actual shape looks like. You can also create your own shapes in here. So if you want to create your own maps, create your own shapes, you can do that. You can also use this other product called MapShaper. So these are all publicly available websites. MapShaper is really good if you want to simplify your shapes. So they've got a whole load of algorithms in here where you have really complicated and really detailed geospatial shapes. You can come in here and you can actually simplify that and get rid of a lot of the points. That has a massive optimization benefit to you. So you don't need that level of fidelity. You don't need to know every meter of the outside of the shape of South Africa, for example. You just want a generalized version of that. And you can basically simplify it in here, and therefore your data type and the amount of data you're storing is much, much smaller. And then Mapbox is great if you want to create custom maps with different color schemes, and there's a whole load of configuration that you can do here to make the color of your map look great. They give you something like 200,000 tile generations a month for free. So basically, if you embed this into your kind of Python project that you're building, you can basically render 200,000 map images for free every 6 months. So visualize. Well, it's not a visualizer. You go in here and you create your custom map. So you can say, I want roads to be black. I want the river to be green. I want whatever you like. You can customize different types of building. You can customize whatever you like. And then basically you can embed this then into your own Streamlit app, for example, as a background layer. And then you can obviously overlay your particular shapes that you're generating from your actual application. For example, if you're using, again, I'll reference things like Power BI. Power BI had a custom visual that you used to be able to embed MapShaper as the background. And you can get a really on-scene brand map background. Sticking with Mapbox, and I know, again, Peter's going to talk about this, isochrones. So that's not a circle around a point, but actually travel distance. So essentially, in this example, you're saying, how long does it take me to walk from this location? So what's my catchment area? If I wanted to get people to my store that was in this location that was 10 minutes, yeah? So I think this is based in New York. It's looking at the way in which the traffic flows and all these other things and saying, cool, this is the travel time to get to that location. So isochrones are really cool when you're looking at what's your catchment area rather than drawing a circle around it. So if you did that on the basis of C point, you'd have your catchment areas being somewhere on Table Mountain, which it's not. But isochrone will take that into account and go, this is actually your catchment area. Well, there's just a couple of quick demos. So I've taken data from the Ordnance Survey. I've taken data from the UK's Met Office. So this is, I've actually taken weather data that basically shows you how much sunlight there is every day. And then I've taken a data set from Carto. So Carto is a software that you can plug on top of Snowflake. It basically allows you to do really cool geospatial analytics and visualization at scale with really high levels of fidelity. Expensive, but it's like a sort of geospatial analytics tool. And they kindly make available a whole load of data sets on the Snowflake marketplace. Some of them are free, some of them are paid for. What they also do is they also make available a whole load of functions to work with those other two indexing systems that I mentioned, that Quadrant and S3. Carto provide a mechanism for you to actually interact and convert your data into those formats. So it's a really, really cool company to follow. They've got really cool data sets. And if you go and follow their website, they do really great analytics of geospatial machine learning based analytics. The data set I've taken from them is basically they provision. Come on in. Welcome. So basically, how's it? They provision a whole load of different data sets. The one that we're using is a global buildings data set that has a whole load of information around buildings globally. The Met Office, like I said, I'm taking weather data. I'm particularly interested in the amount of sun in the UK, so the number's going to be quite low. And then we've got about 6 or 7 data sets I've taken from the Ordnance Survey. So just to give you an idea, so here, for example, Ordnance Survey, you get things like the road network, you get what they call a UPN, which is essentially the unique identifier for your buildings, and all the other things you'd expect, so all the typical geospatial data sets like regions, wards, all that good stuff. Met Office, they're giving the weather by postcode. You get national weather warnings, so when there's a flood. And then, like I said, on Carto, there's all sorts of different data sets. This is the one I mentioned here, the Carto Analytics Toolbox. You can basically install a database, obviously, it's a data share in your environment that has a whole load of functions in there that you can take advantage of and do geospatial analytics. A lot of them are kind of machine learning-y, so you can do all the sorts of all different types of aggregations and analytics. So these are all the different data sets that I've extracted for this demo. I'm not going to show you like all the code behind, but there's the Carto buildings data set, there's the Met Office data set, and then there's all these ones from Ordnance Survey. So buildings, extents, which is essentially like geospatial boundaries, postcodes, roads, and then this unique identifier. So this is the one kind of use case here. So basically it's taking a particular like city or town. In this instance, I'm choosing Exeter. I've got loads of postcodes in there. So I've mangled all these data sets together. And then within 500 meters of this postcode, like as a boundary, on the 1st of January, I want to see what the weather was like. So how much sunlight was there? It's trying to predict the amount of energy that I can receive from the sun. So now I've gone and found all the buildings within that postcode, and I've done a bit of analysis. You'll see just now that it will show you some, it's basically figured out what the angle of the roofs is on these different properties. So which way is the roof actually, and this is all data that's in the Ordnance Survey data sets. So is the roofs of these properties facing north, south, east, west, now I can go in here and I can play around with what do I think are inputs to how much sun would fall on the southeast facing roof. So I can go and fiddle with these inputs, and basically it's going away and recalculating which properties would be really like efficient for generating solar energy. So it's quite a cool use case. If you're selling solar in the UK, I'm happy to share this with you. And you can go and find a whole load of customers royalty free. But what's really cool is I've brought the weather data in here, I've brought my buildings data, and one of the data sets also has building parts. So it takes a building like this and it will segment it into different parts of the building, particularly like, say you're on a university campus. The university is a building, but each of the other buildings is like a part of the campus. So here it's actually finding out what's the best building in this map that I've created. If you go, I've got all my solar panels on. It's actually found here a cathedral, Exeter Cathedral is the best. It's got loads of roof, it's got no solar panels already, and so it's a really good one for me to go and put something on. But now I'm going to take all the inputs from my weather data, my building data, and all this. I'm going to run Cortex Analyst. I'm actually going to create myself a narrative. So I'm going to take all that data and it's going to tell me all this information about the building, the shape of the roof, the total square footage, all that good stuff. It's going to give me a whole description about the actual building, some things history. All this data comes from those 3 or 4 different data sets, but I'm able to synthesize that now to make it something that's quite readable that maybe I could print off and go and take to the cathedral people and say, hey, look, it's really sunny where you are. So this is one example of how you can take lots of different data sets together and create, like synthesize them together to create some kind of analysis. Just want to show you one other example here. The same model. Obviously, the UK does get some sunlight, but obviously in winter time it's much, much less. That was on the 1st of January. So again, this is a different little village or town. And what I wanted to show you here is just how, for some of the data, we actually get 4 dimensions or 3 dimensions. We get not just the kind of plan, but we get the height information as well. So we can draw these quite nice 3D visuals of the actual buildings and what they've done. And this is using a Python library called PyDeck, which allows you to generate all these different types of visualization. Last kind of demonstration. So this is using all the data from the Ordnance Survey. So here you can see, and it's taken a sample of this. I didn't want to smash all my credits. So it's taken a sample of the roads randomly. It's basically found all the connection points in these road networks. Then this is my hometown. And it's basically plotted all of the buildings and all of the road network here. So again, if you're doing some kind of town planning, you could go and start segmenting this. You could go and start looking at what kind of buildings are there. You know, it has interesting information around the buildings, whether they're derelict, whether they've been built, whether they're newly built, whether they're being built, the size of them, aliens when they were first registered. So there's loads of interesting information you can pull from this to do like quite interesting geospatial analytics. You can see here you can calculate a whole load of obviously metrics at the same time. And just one last example. This probably took, I guess, the best part of the day to put some of these things together, figure out what was in the data sets, how you could join them all together, what you actually needed to do to actually get all the data sets to talk to each other. Here you can see this is a small village where you can see, again, the road network. This is the village green. You can see all the different houses. You can see each of their unique identifiers. So here the UPN number, and that UPN number you can link to other data sets within the OS like data set to actually like combine this together. So that's everything from me. That was like a little precursor of like how you work with geospatial data and some of the data sources, some of the tools you can use, some of the kind of outputs. I'm going to hand over to Peter now from Wonga to share his story. Oh.
Just the big one.
The big one, yeah.
Okay, hi guys. My name is Peter Faes. I'm so glad that Douglas spoke before me because this is sort of just like explaining to you if you have a problem, how to find a solution. It's going from getting the problem to mining the data to using the data to giving people an idea on how to set a schedule. So yeah, it's a big thing. Not all of it is Snowflake, but you know, you can't always start at Snowflake. You have to start at the beginning. Just some information about me. I come from a small town in Limpopo. I normally see the best thing that comes out of Limpopo is the road. So I'm in town saying that it's already here. I worked in manufacturing for quite a bit. Then in 2021, moved into data science. And I've been part of Wonga since 2022. Of 2022. Then what's Wonga? So we're a short-term lending company. We started in 2015, coming from the UK. We do loans between 500 Rand and 8,000 Rand with terms of 4 days and 6 months. And then we disperse in less than 15 minutes. So that's majorly my work, is to make sure that everything runs as fast as they can and without people, so that we can do that in 15 minutes. We have a net promoter score of 89. I wanted to put in the amount of disbursements, and the marketing was like, no, you have to say this. That's marketing's part. So how this whole situation started was actually a Jira ticket from marketing, where they said use LLM to clean addresses and postal code data for marketing. And I was like very excited because we can use LLMs, but then I started reading and I'm like, this is definitely not something LLMs can do. And basically what I wanted to do was they wanted to be able to see what billboards they want to get from Prime Media is going to be the best billboards and what's the performance of the billboards. Because you can put the same billboard on the N1 in Joburg or a much smaller route, maybe the R21 in Pretoria, and you know, the one might get there and the other one. So then I said, okay, well, I'm breaking your dreams. We're not going to use ChatGPT, but maybe there's something else. So then I started looking at, well, what do we have? We need a way to say our customers are moving from this point to this point. And I know from knowing the data is you have their home addresses. So that could either be a physical number, like 14 Cliff Street. This is Wonga's address, so I'm not giving something away. But we have a physical address, or we have like the street, which is fine. They have to go past the street. And we do have the employer name. So now we are jumping a little bit, but we can relatively say, you know, what path this car is going to take when he goes from his home address to his work address. And then we also have some extra information like industry. So if we are looking for something like Dumela, consulting, we can pretty much see, are they electrical consulting or they whatever, they can narrow down the results that we can get. I then took all that data and then I was like, okay, cool. I have this data in text. How do I get it on a map? And what I then realized is I'm going to have to use some APIs. And these APIs would then allow me to like basically quickly go into Google Maps, search the thing, get the coordinates, and then I have an idea where that point is, do the same with the work address. And then we can see, okay, from this coordinate, we have this coordinate. So that's the next thing. So I tried a few radar.com map box that Douglas spoke about, Amplify, geocoding, Page, and they were good in certain aspects, but what normally would happen is if the input is something like 123 Snowflake Avenue, Joburg, most of them would give out just Joburg's address. So now you have all these home addresses that everyone just works in the center of Joburg, and that's not accurate. But what ended up happening is Google Maps was the most accurate. So they would always give you something that's pretty much accurate. So for all the ones that, like, let's say 90% of the ones that other APIs failed on, Google actually got. But the problem is some of these are quite free or they're more lenient. The Google Maps is not that lenient, but there are ways around it. I think that I'm discussing it in the slides, so we can talk about that, but we decided to go with Google Maps. So the next problem we had was, what if a customer works for KFC? So there's a lot of KFCs, there's not one specific one. So how do we handle those? So we ended up just making an assumption saying that a person lives closest to his work. So if he lives in this place, he works at the KFC closest to his home. And that's a rough assumption that we're making, but it was just something that we can get over that hurdle and just go to the next points. Then we were like, okay, great. We went from text to coordinates, but now how do we say, draw me a line between these two coordinates? So we looked at a few solutions. One of them was sticking with Google, and it became even increasingly more expensive. And we went from maybe this is going to cost $100 to okay, this is not costing more than $1,000. So I started looking at other examples and came across a service called Open Route Service. And they pretty much great. They have a few APIs. One of them is the direction. So when you say you have one coordinate, you need to go to another coordinate. Isochrones that Douglas also mentioned. So basically it puts a point in the middle and then gives you time from that central point, and it changes as you don't have routes in that way. And then optimization also, if you have 2 points, you have to find the most optimal point between these two. It's quite nice. The only caveat with this is you are rate limited. So I think you can do like 40 requests in a minute, and also I think it's about 1,000 in a day or something like that. There's also ways around that. But you can talk to me afterwards about that. I'm not going to say that on the live stream. So then we have the coordinates, we have the route, but now how do we display this? Now, if you have been working with some map stuff, you would know one of the solutions is a package on Python called Folium. So Folium would give you an HTML file, which would be the one at the top over there. Which is super nice. You just down and dirty have to get something out. But I had to do this for Joburg, and then they were like, okay, cool, this works great. Let's do it for Durban. Let's do it for Pretoria. Let's do it for Cape Town. And that information is not going to be static, because in a few months they're going to come back and say, oh, you did 25% of all the people that we know, let's do 50%. And then you have to have a way where they can go to one centralized point, and then you could say, okay, just I'll update it, just look at the same place. So that's actually when Snowflake came in. We can just put all the data to Snowflake, store it over there, and then just point them to a Streamlit app where they can make all the changes they want. They can orientate it in the way that they want, make dynamic changes. And if they need more capabilities, they can just ask us. We can just add it and evolve it. So this is just a small demo on the Streamlit app that I created. The plots is the coordinates of the billboards that they were looking at. The lines was sort of like the amount of customers that passed it. I ended up designing it in a way that if more customers pass it, the color of the line would change as well as the thickness. So the thicker the line can be like, okay, there's more people there. This is Victoria, not as much, but you can basically see, oh, okay, a lot of people are working in Joburg and traveling from Victoria. So it is quite interesting to see how the people would travel. And then marketing would go, I could have just worked out the performance of each billboard, but my marketing likes to see stuff. They like to see stuff and sniffle in between and see how many of our customers live close to their homes. So this is quite a close street to where I live in Cape Town. And this is another one close to Parow, so they can just check that out. I think this is the last. Oh, then Joburg. This one has the most billboards, and the sort of like the biggest area. You can see there was a big thing that had like 700 customers going past there. Our small data set, and then there's a bigger one. There's a billboard with computer science. And then you can zoom in. You can see this one has more, and hopefully it's cheaper. So it's something that marketing can use and see. Then just a few challenges that I've struggled with during this. The first one is, I don't know if it's going to, no, it's not going to play. Okay, but basically that is Boris Johnson saying ChatGPT the whole time. But one of the problems I had was I was new to Streamlit, so I was used to a framework called Gradio that you use in Hugging Face, but not to Streamlit. So I ended up just asking Uncle ChatGPT to help me with everything and say, oh, I need this and I need that. And I know it's in programming not the best thing to do, but it just helped me get me over the line. And some of the more difficult problems I did struggle with, and I did manage to understand what it was trying to do and fix it myself. So I'm quite proud of myself for that. But the rest of it, I just use ChatGPT to get through it. Most of it, and it's really nice if you can just describe the data structures in Snowflake to it and exactly what you want it to do. It worked really great. The next thing is inaccurate data. So this is sometimes inaccurate because of the searches that we're doing, but also remote workers. So a guy lives in Joburg, but he works in Nelspruit. So we would have like this sort of like biological cell thing that forms. So I had to filter and say a person's home address and work address is more than 100 kilometers from each other, and it's probably not the people that we want to. Then also Streamlit performance. So in normal HTML, you would use a package called Folium. Struggled a lot with Folium. Didn't want to show up in the Streamlit app, so I ended up using PyDeck that I just also mentioned. And it's super great, but there's a lot of calculations in the background that needs to happen. And then ended up optimizing it in a way that we only display routes that has more than 3 people traveling on them. And we also limit the amount of routes that we want to show and push all the Python that we have down to SQL, because Snowflake is SQL and that's the most the best performance. So I pushed that down just to get the most out of it. I think if I had to look at it again, I'll probably just create all the maps into a table and then just read that data from a table and plot it, rather than just dynamically updating it as you change stuff on the Streamlit app, just because I realized marketing doesn't want to look at a specific customer. They want to look at all customers, and that's always going to be. So just going to go along with that. And then the API cost and rate limits. Yeah, this was quite a big one. You can't really see it, but I'll read it for you. So the way that you would do it is Google has a thing called Places API in brackets here, because I named it. And you have something called Text Search Pro that costs you $32 for every 1,000 calls you make after 5,000. So that means for my the project that I had to do here, the cost would have been like $1,480 just to do that. I ended up finding out that you can use the same API and just get the Google Maps ID of it, and then use a different API. Let me say on their source package, and it's the geocoding. And then your cost goes down from $32 per 1,000 calls to $5, and that brought down the cost to about, I think it was $200. So it's just the way that you use it. And you use these API calls just to get that done. And then I have some future improvements. The H3 indexing that Douglas was talking about is super nice. He explained exactly how they would do it by dividing it into polygons, hexagons that would then go smaller and smaller as you get closer. And the reason for that is just the other data sets you can easily join into it. So moment I had like the travel path and the count is by the color, but if we go into not only does our performance go up, but we can get stuff like traffic and mobility, the population in that specific block, traffic congestion. Maybe you want people to look at your sign of your billboard for longer because they need traffic more. Public transport sports, so it means there's more foot traffic around that. For instance, like taxi ranks, hospitals, fast food restaurants, and then also economic activities. Who's the type of person that moves past there? How does the road look that where your billboard's going to be? What do you want to be? The billboard someone sees when they go through a pothole or something like that. Okay, and that is basically that was my life for 2 weeks. So now business. Is there any questions on this? Yes.
Curious, you have to make a batch requests to the open routing.
Sorry?
You have to make batch requests to open routing to get the actual.
Yes. So I think I took single request, and then they would send you back a JSON that has all the information like the travel time and the sort of like a coordinate map of exactly between the 2 points. And then you would just call them and just make sure that you do less than 40 in a minute, and just make sure you stay clear of the rate limits. Otherwise, the program's going to go very fast, but it's going to throw errors all the time.
Then, okay, when you how are you going to get hexagonal patient data for H3?
Oh, for HP, it's at the marketplace and at Snowflake. So that would be the easiest way. Hopefully in South Africa, there might be some census data that can help you. I don't think there's someone in, South African government that has thought of H3 and thought, okay, maybe we can put population data into this. But maybe there's something like that. Maybe there's something else that you could use. Some company, you might have to buy it. But it might be something that's worthwhile. Yes.
For the spots where you had your billboards,
Yes.
is that existing places where billboards are? Is that so?
No, it's existing. It's so if you go to Prime Media and you say you want to get a board, they'll send you a whole PDF with basically a picture of the board, what the board is, and the coordinates of exactly where that was.
I was wondering that predicts this is where you should put one that you got land you could use or whatever.
Yeah. That would be another use case that was pretty nice. Where we put up. Yeah. Sorry.
Well, just information is that pretty much a structure specific. Some of those responsible purchases or can you find correlation between fields.
The postal code?
The address.
Yes.
structured number three.
Yes. Yeah, so it was basically if someone would apply for a loan on a front end, it would be your street address, your city, and then your postal code. We also use the postal code to define if someone is in Joburg or Durban or Pretoria or you know.
Few online questions. I think you've answered this one, but maybe just recap. There seems to be no freely available data in South Africa. That is population data.
Yeah.
So that's it's 3 down to 3.
Okay, so the contour data set, I'm pretty sure there's a lot of data sets. I just didn't have any time to go look into it because after a week, my manager was like, well, how long is this thing going to take? So then I had to be like, I'm just going to finish it. And then I told marketing and their eyes were quite wide when I told them about H3. So hopefully that's a 2026 problem. Yeah.
Then there's always a question about Snowflake credits. Snowflake credits for the presenter is $150 less. Is this due to the project cost or is it the other one?
No, it's pretty much all of the other thing. But that's the nice thing about Snowflake demo cards. So, yes.
Digital was marketing, so obviously for customer acquisitions, how worthwhile was it? How much lift did you see? Was it business use case? Was it applications, disbursements in certain areas?
Yeah,
How long did you-
yeah, that is a difficult thing, and that's what my question to marketing was as well. Is like, how do you know this worked? You know, because you can say, oh, we got more people, but then you have to be like, yes, okay, but is this billboard working? And it's the same question I said to Douglas, and he told me about some of the cellular companies that would sell data off your phone that was tracking, and they can basically see if you passed by one of the billboards and then say, oh, did this guy be converted? And then you can say, oh, he passed by the billboard. Okay, that means something like that. But other than that, you could just say, well, in the past, we had billboards at random positions and we got this turnout, and now we change it and now something changed. But it's very difficult to say.
I think so. It's also very visual. We spend also this like you got that something called said by me setting a
Yeah.
but I don't have my customers that are like the
Yeah,
on that room is was spending big versus out of over.
exactly. Yeah. So it's the best estimate we have. So, yeah.
Just on what the attribution, how did you go about just have QR codes just to try actually not to say it's specific came from a temple and this global attribution.
So we don't at the moment we haven't mentioned this yet. So we haven't put up the billboards yet. But this was sort of like if they had to pick and they have to have more information than they have at the moment, that's the more information we give them to sort of like help them know a little bit more. But there might be ways that they would do it like that. I think at the moment they would just go as, oh, we see more people as passing past this. So I think it's the best option we have at the moment. But maybe QR codes and stuff like that could also work. Yeah.
Last question.
Okay.
Geospatial. Since you give up something 8,000.
Yes.
One cent each was 8,000 should be interested in fees. So it should be around 7,200.
7, yeah, it could be that the stuff the 8,000 rand is inclusive of fees. I'm not totally sure, but yeah.
Yes, I would know. Something that's in the room. But the one question I had in the beginning was why are they focusing on the existing customers? That's the starting point for trading.
Because we do not know who's our new customers going to be. So new customers, we can see guys that have applied, and if they got a loan, they're existing customers. We don't know who our new customers are going to be, but our sort of like idea was if we can see where our existing customers are moving, that could be an indication of where our new customers could come from.
Yeah, so the same thing because you know the most problem when it comes to attribution tool question was how do I prove books?
Yeah. Yeah.
Unfortunately, is that there's a complete should miss effect.
Yeah.
When it comes to both specifically it's for brand names. What we're trying to build is what brand new corporations. And that's impossible to measure.
Yeah.
Use which is things like shared search for brand alternate brand names.
Yeah.
It's a proxy that shows kind of down clicks of kind of senior brand name. When you can do combinations and it's not as close as you can get.
Yeah.
Right, you're starting attributions like QR codes and stuff. What ends up happening is essentially just serving the in-market buyers, which is that point of why I asked why existing customers.
Yeah.
Essentially, really serve those people that are aware of, are checking those one things here, are they consistently coming back?
Yeah.
So that would make sense from a strategic perspective. But for the most part, most companies, they flatline without growing it. It's not doing the marketing on the market buyers. So ones that don't know who they are, and that's where broad reach comes from. It's not doing reach.
Right.
It's trying to prove the return.
Yeah.
And our essentially courses are flatlining growth. So that's what's also suggestions in the frameworks. And that's what I'm saying. Yes, cool. Thank you.
Cool. Thank you, man.
Marketing advice for marketing.
Yeah. Well, they should have been here. Yeah. Sorry, at the back here. That is a very good thing. It is something that when I started this project, I'm like, why don't we use sort of like a Google Maps API plugin there to, if someone says this is my address, you can just pick it from the results that show up. And then they were like, oh, okay, we're gonna. So from this point, it is there and it's much easier for me now. But it was something that they didn't think of prior to this project. Yeah. Yeah. So any last questions? Yes.
Yeah, so like they say, like Snowflake, it's a small data set. On the Postgres database, just work. Why do you need?
It's at the end of the day, you have to think of the end user, and I had to get a place where that person can get the easiest access to that. And to me, that was just Snowflake, Streamlit. There you go. You can have access to it. You can assign roles to you. You can only see certain data. If we want to create multiple apps because we only want a certain person to see Joburg and we only want another person to see Durban, we can sort of like give them RBAC access to those specific stuff. But where if you would save it in, you can save it in any database, but it's just getting access to it and then having a cloud platform where they can go to a centralized stream with that.
Yeah, maybe the question, like, I don't think Wonga chose Snowflake for this project.
No,
Snowflake is the like
was already there. Yeah.
for the company.
Yeah. Cool. Thank you, guys. That was a lot of questions.
Cheers, Peter. That's really good. Cool. That brings us to a wrap. But now, as always, it's quiz time. So, get your QR codes out. We're going to attribute this now. You're a statistic. Yes, how many people log onto my slide? Well, this was. You should be able to join the quiz. There we go. Well done, Bronwyn. You're keen. There's no prizes for you. Yeah. The prizes are in this box. It's like a lucky dip. There are teddies up for grabs. They are like gold dust. Perfect Christmas gift. Look at that. On theme, on brand. I'll give you guys. Beta girl. Okay, someone's keen. Geospatial, that's very good. Okay, I'll give you guys a couple more minutes. Alrighty, there we go. There's 7 questions in total. They're not difficult. It's just a bit of fun. Okay, we'll go for the first question. I've got 20 contenders. 21. I'm going to give people 30 seconds. You guys good there? I can see you guys are struggling. Peter, you should know all the answers. Okay, we're gonna go for it. Okay. Late arrivals. Okay, here we go. Okay, the first question: which of these are geospatial data types? Select two. I'm going to be generous with my hints. This is a reflection on you as it is as much on me and Peter. And the answers were geography and geometry. So if you answered both of those questions right, well done. We're going to steamroll through these, so there's no leaderboard. This is going to be straight through to the end. Cool. Which of these are not geospatial shapes that I talked about earlier on? Line string, multi-line string, path, or polygons? Voting closed? Really? Excitement and now the wait. Let's try this. What's going on? It's all good again. Go for your life. You sure? We'll see. This is not how it's supposed to work, but anyway, good on you. No, this is not working. What? It's just let's see. Okay, so path was the odd one out. Okay, which of the following are data providers on the Snowflake marketplace? It's getting really difficult. Remember, it's all about speed and accuracy. All of the above: Ordnance Survey, the Met Office, and Carto are all data providers. Well done, 73% of you. Next one: which of the following will help you visualize geospatial data? Streamlit, zero copy times, Geospatial IO, or polygonomy? You choose. Well, you choose. Oh, well done. Hopefully. Streamlit with PyDeck or Geospatial.io. So we're ramping our way towards the end of this highly intense question and survey. Native. Go for it.
Yeah.
Hey, go again. Go again.
also include now your anti-aging tools on capabilities.
Well done, some native is the. Oh, I think we've only got a couple of questions left. What does Wonga do? Home loans, insurance, short-term loans, or deliveries? Well done. Well done. Marketing will be very happy. Don't worry about that geospatial stuff, man. Just slide. Well done. Cool. I believe this is the last question. Okay. Here we go. What API did Peter use to determine the travel route? The travel routes: Google, Open Route Service, Bing, or Uber? I hope I got this right. Open Route Service. Oh, and there's your winners. You mean? Oh, well done. Oh, that's it. That's us. That's a wrap. Thank you very much, Peter, for your presentation. Thank you all very much for coming. Please keep an eye out for the first event, which will be in February. And it'll be either here or at our other workshop 17. As always, we need your rating. So either it's good or it's bad, no pressure, no peer pressure. So on 3, 3, 2, 1. That's good.
Wait, keep it like that.
Oh, thank you very much. Cheers.
Thank you.
The top 3, I've got prizes for the top 3. Cool, thank you for joining online.
Thank you. Bye.